Yeah, first of all, I should wish you good morning, all of you.
Good morning, ma'am.
Good morning,
And
ma'am.
thanks. So, yesterday's portion, hope you had gone through. If you have gone through, did you find any problem?
No,
I'm
ma'am.
waiting for the answer. Okay, no. The rest of you, please answer me. Did you go through the content, what was taught yesterday? Because everything is in continuity. If you don't revise that, it will be difficult for you to understand today's lecture. That's the reason why I keep on saying, please revise at home. Okay? One question. Am I audible to all of you?
Yes, ma'am.
Yes,
Okay, then
ma'am.
I need the answer. Then I need the answer because there's absolute silence from your side. Should not be. Right? The first thing that's what we are going to describe today is how do we represent motion graphically. Okay? The first graph that we are going to deal with is distance time graph. Now, yes, please start reading and read a para and then I will explain. Please do so, Vita. Start reading, please. Please start reading, Vita.
From distance time graphs,
Yeah,
the change the change in the position of a body with the time can be represented on the distance time graph. In this graph, distance is taken on the y-axis and the time is taken on the x-axis.
fine. Now, distance time graph is what? What exactly is distance time graph? D upon T? What are we trying to find out? Speed, isn't it? Speed is equal to distance upon time. I think we did it 2 days earlier. The formula, speed is equal to distance upon time. This is what we are going to find out. Speed we are going to find out. And how we can do that? When we draw a distance time graph. As simple as that. The very first thing that what you have to do is you have to take time on the x-axis and distance on the y-axis. You cannot change, you can reverse it. So time has to be on x-axis and distance has to be on the y-axis. Fine. Let's
The
start.
distance time graph for uniform speed is straight line, linear. This is this is because in uniform speed a body is travels equal distance in equal intervals of time.
Okay,
We
I think
can
you agree. Just a moment. Whenever I interrupt you in between, you have to stop it. Okay,
okay, ma'am.
fine. Now, what is this? The distance time graph, we are always taking uniform. We will never take non-uniform, generally to make you understand. So it's sort of a set that uniform speed. Obviously, I have told you last time also, whenever we are showing a straight line, it shows either it is uniform motion, it could be uniform velocity, it could be uniform acceleration, and so forth. You understand? Straight line means uniform. It could be speed, velocity, acceleration, anything. Okay? So it is also called the straight line. I think you know that in maths it is called as linear. What it is called as linear. Because we know that the speed, the uniform speed of any body XYZ will travel always equal distances in equal interval of time. We know that. That's why it is called as uniform speed. Speed is equal to distance upon time. Uniform speed is equal to equal distance upon equal time or equal intervals of time. You understand? Hello?
Yes, ma'am.
Yes? Fine. So this is what we are going to plot and this is how we can determine the speed of the body. Yes. Go ahead.
We can determine the speed of the body from the distance time graph. For the speed of the body between the points A and B, distance is s2 minus s1 and the
S1
time s1
is,
and time is t2 minus t1.
okay. Now let's see. Now we are finding
Uh,
the speed, right? We are finding the speed. Now I will take over here. Now look at the graph. Please have a look at the graph, right? Now when this is 5 second, you understand? This is 5 second. The distance is 10. It could be meter, kilometer, whatsoever. Okay? This is initial time. The final time T2 is 10 seconds. And the final distance that the body will cover is 20. Got it? So this is the distance covered in this time. You understood or not? And hence we get a straight line as the plotting. This is the straight line. This shows that the body is in uniform speed. You understood now? In T1, we have this S1. In T2, we have this S2. So we already know that speed is equal to distance upon time. Now here distance is S, S upon time. Is it clear? So what is S? Final distance minus initial distance. And what is T? Final time minus initial time. Is it clear to all of you? Hello? Is it clear
yes,
to all
ma'am.
of you?
Yes.
Now start. What is
V
V?
is
V is, what is V? V is speed. What is V? Because we have taken S as distance. So V is taken as speed. Okay? V is speed. Now V is equal to what?
speed.
No. V is equal to speed, I know. But I want to ask you to tell me the formula. Speed is equal to distance upon time. And distance is S. What is distance, beta? What is distance? S. It is denoted by S. Speed is denoted by V and distance is denoted by S. Okay? Divided by time. So V is equal to the difference in distance is S2 minus S1 and difference in time is T2 minus T1. What is S2? 20. We got 20 over here. What is S1? 10. We got 10 over here. Okay? The same with the time. T2 is 10 and the T1 is 5. But we got 10 upon 5. So we got 2 meter per second or 2 meter second inverse. This is how we have to find out the numericals. Any problem, tell me.
No, ma'am.
Okay? John?
Yes, ma'am.
Yeah. Is it clear?
Yes, ma'am.
Zamin Raza?
Yes, ma'am.
Yeah. Do you find any difficulty in understanding it? Are you finding any difficulty?
No.
So the first thing that you have to say is that whenever we get a straight line, that means it is a uniform. It could be speed, it could be acceleration, it could be velocity. Okay? And this is how we have to find out. These are all mathematical notations. Now we are going to work on, that was uniform motion. Now we are going to work on non-uniform motion. Yes, please read.
The distance time graph for non-uniform motion is non-linear. This is because in non-uniform speed a body travels unequal distances in equal intervals of time.
Fine. Let's check the graph. This is how we do the plotting. 5, 10, you can see this? 15, you understand now? So at the equal interval of time, we are doing the plotting. But remember, in 5, we have got 2, right? In 10, we have got 8. Hope you understand that. So it is see uneven. The distance covered is uneven. You're understanding what I'm saying? So equal distances are not covered. Unequal distances are covered in equal interval of time. Hence it is called as non-uniform motion and hence we get a graph. So it's a curved graph. Can you see this? It is a curved graph. Had it been straight line, then it would have been uniform. If it's curved, then it is non-uniform. Why? Because at equal distance of, sorry, at equal interval of time, unequal distances are covered. Hope you have understood. There's nothing much to add over here. So if you're getting a curved graph, what does it suggest? It is non-uniform. Okay? Please respond. Hello?
Yes, ma'am.
Yes, please respond, I said. I do not know whether you are understanding or not. So let us say yes or no. Okay? Fine. So can I go to another slide?
Sure, ma'am.
Which was this graph? Distance time graph. Please remember this. This was distance time graph. Now what we are going to do is velocity time graph. Okay? It will be same, almost the same. Please read.
Velocity time graphs. The change in the velocity of a body with the time can be represented on the velocity time graph. In this graph, velocity is taken on the y-axis and the time is taken on the x-axis.
So what you should remember always, the time is always on the x-axis. That thing should be in your mind. Time is always on the x-axis. There should not be any doubt about it. Okay. Now, my question to you is, I'm talking about change in the velocity. Obviously, it has to be with time, per unit time. What exactly is it? What it is called? What is the change of velocity called? What are we defining? See, we have learned everything. I will not ask anything which I have not taught you. So my question is to you is, what exactly is the change in velocity? What it is called? What is the terminology? What does it denote? What does it show? What does it represent? The change in velocity is equal to what? Hello? Hello? In the last slide, we did speed. That is change of distance per unit time, isn't it? Now I'm talking about change in velocity per unit time. What is it? That was speed. Now what is this? What is change in velocity suggest? It's acceleration. V minus u upon t. You forgot? That's the reason why I keep on asking you. Did you revise? If you revise, then you remember. If you don't, then you tend to forget. Do you understand what I'm asking you? Hello?
Yes, ma'am.
Yeah, you got my point now? That I will be asking you certain questions in between. If you're thorough, then only you can give me answer. So from today onwards, will you start?
Yes, ma'am.
Thank you. Be punctual. It will be very easy for you to understand things. Okay. Now I hope I've told you what it is. So what is change in velocity? It is acceleration. What it is, beta?
Acceleration.
What was that formula? V minus U upon T. Remember? V minus U upon T. Final velocity, initial velocity per unit time. That is acceleration. Now read.
If a body moves with uniform velocity, the graph will be a straight line parallel to the x-axis. This is because the velocity does not change with the time. To determine the distance traveled by the body between the points A and with
Velocity
points A and B with the velocity 20 kilometers
per hour.
minus 1
No, per hour. Say 20 kilometer per hour
per hour.
or 20 kilometer hour inverse.
Ma'am, I have a doubt
Say
that sine of h
just a
raised to
moment.
minus 1,
Yeah, that is what I'm talking about.
that
This is
is
just.
mean per
See
hour.
what I showed. Just a moment. What I showed you just now. Did you understand? Did
Yes,
you
ma'am, I
understand
got
or
it.
not? Okay,
Yeah,
you
yeah.
got it. Now the same thing I can write it as 20 kilometer into 1 upon h. Can I do that? Can I do
Yeah,
that?
ma'am.
1 upon h?
Yeah,
Okay.
yeah.
Same thing, 20 kilometer. What is the 1 upon h? H I will take it on top and it will become inverse. That is maths. I'm teaching you maths right now. It is inverse. When I take h on top, 1 upon h, 1 upon 10, it becomes 10 inverse. Remember? 1 upon
Yeah,
10,
ma'am.
10 inverse. You understood now? So this is how we have to notate. Give the notation. Okay? Fine. Now, if a body is moving with uniform velocity, that means if I take it, it's written over here, 20 kilometer per hour. Obviously, velocity is on the x-axis. Can you see this? Velocity on the x-axis. Yeah, 20. You can see the straight line? Yes or no? So if you are in 5 seconds, you will see 20 kilometer. 10 seconds, again 20 kilometer. Because the velocity is not changing. So the plotting, the graph will be straight line. It will parallel to the x-axis. You agree with me or not? 10 seconds, 20 kilometer per hour. 15 seconds, 20 kilometer. So this is the plotting. The velocity is not changing. So it will be a straight line. All of you agree?
Yes, ma'am.
Okay. What is the formula of velocity? Distance upon time. That's not what we did just now. So velocity is equal to distance upon time. This I'm going to teach you now. So what will be distance?
Hello,
It will
ma'am.
be
If you
V
can hear
into.
me,
Yeah, I can
if
hear
you
you.
can hear me, your voice is not coming clearly, so मैं
Now,
वापस कट करके वापस आता हूँ.
now. Hello, is it okay now? Hello,
Yes,
John,
ma'am.
can you hear me?
Yes, ma'am.
Okay, I mean, what Sahim said that is getting cut. Is it so?
No, ma'am. Your voice is coming absolutely
Clear?
Actually,
properly.
ma'am,
What happened?
there's a network error in my
Okay, no problem, no problem. Now
SIM
is it
card. That's
okay?
why.
Okay, now is it okay?
Now it's okay.
Okay, fine. So whenever this sort of things happen, you leave and then you can rejoin.
Ma'am,
Okay, that's it.
it needs refreshment. Like,
I know. So that's the easiest way to continue. Fine. So wait. So velocity is distance upon time. Now we have to find out distance. So what is distance? Velocity into t. Yes. So we are cross multiplying it. Yes or no? What is velocity given? 20 kilometer per hour. And what is the distance? What is distance? I will show you.
20 kilometer per hour.
No, distance I'm talking about.
Oh, okay, ma'am. Sorry, I.
Distance I'm talking about. So what is the distance is? C. This is the distance. AC or BD, the vertical lines. This is how much it is covered, isn't it? This much of distance is started from here and it is reached here, isn't it? So this is the distance. Understood or not? Because distance has to be from the x-axis to the y-axis. So it could be either AC or BD. Okay, and what about time? What is a T2? T2 is 15. What is T1? T1 is 5. So it is T2 minus T1. And what is T2 minus T1? That is DC. Can you see this DC over here? This is D and this is C. So this is what we have to take as for the time. Got it or not? So V is AC, that is AC over here. And T is T2 minus T1. And what is T2 minus T1? 15 minus 5, that is DC. That is DC or CD. So we have got AC into CD. So what will be the distance? Distance will be this much. Area of this, either it is square. Now here it looks like square, isn't it? But here it is written rectangle. But it could be either square or it could be either rectangle ABDC. So this is what is going to be the distance covered. Now tell me if you have any problem in understanding. When we do more numericals, you will understand more. This is how we have to. I'm just showing you how to go about it, how to find out the speed or acceleration or velocity by the graphical notations. This is what I'm going to teach you. Okay, and based on this, then we will do the numericals. But have you understand the concept behind it? If you wish me to do it again, I will redo it. But you have to give me an answer whether you have followed or not. If you have followed, till where you have followed and where you are finding difficulty. Boys, I'm waiting. Hello. Hello. Can you hear me? Boys, can you hear me?
Yes, ma'am.
Yeah. Is it clear or do you still like are you confused? Hello.
Yes, ma'am.
Is it okay? Did you understand or not? This is what I want to do. Or you want me to redo it? Yes? Hello?
Ma'am,
Yeah.
please redo it.
Redo it. Okay, fine. The whole thing
From the formula, ma'am.
from the formula. That is V is equal to S upon T.
Yeah.
If I ask you questions, will you be able to give me the answer? Because I want interaction. Because you people are not interacting, maybe there's a reason that you are not able to follow. Hmm? Okay. Now, what is V? V is velocity. You agree?
Yeah.
Okay. What is S? What is
Distance.
S? Distance. And
Distance.
what is T? Time.
Time.
So I think the formula is right. Velocity is equal to distance upon time. This you follow or not? All
Yeah.
of you. Huh? Okay, fine. So what will be S? That is the distance. I multiply V and T, isn't it? So what becomes S is equal to V into T. This you follow? So we are going step by step. Do you follow that from where we got S? That is distance.
Yes, ma'am.
Okay, you followed. All of you, ninth standard? Hello?
Yes, ma'am.
Yes,
Yeah.
miss.
So do you follow this from where we got S is equal to V into T?
Yes, ma'am.
Okay, fine. Now we come to the next step. Now what is given? V is equal to 20 kilometer per hour. This is given, isn't it? That the vehicle is moving with a constant speed or uniform speed of 20 kilometer per hour, right? So where is 20 kilometer per hour here? 20. Okay or not? So from here we will count, isn't it 20? From 0 to 20? Yes or no? Say one by, if I'm
Yes,
asking a
ma'am.
question, you have to answer me,
Yes, ma'am.
please. Okay, from 0 to 20, from here I'm counting, isn't it? This line, that is the vertical line.
Yes,
So
ma'am.
obviously it will be from AC or BD. Agree? All the same. 0 to 20, AC and BD, all the same. Yes or no? So either I write AC or I write BD. You agree with me now? This much?
Yes, ma'am.
Yes,
Now up I will go. What is T2? 15. Right? Because here the vehicle stops. Where did it start? T1. Right? So what is the final time? T2 minus T1. So T is equal to T2 minus T1. What is T2 minus T1? D and C. So
C.
it is DC. So this much is the time that we are counting. That is what we are requiring. So DC is the time, right? Now it's written over here S is equal to V into T, right? What is V? AC. So what I will write? AC into what is T? T2 minus T1. Here you can see T2 minus T1. So we got AC into T2 minus T1. Any problem? Any problem?
No, ma'am. No, ma'am.
Okay. Now what is T2 minus T1? CD. Here you can see CD is T2 minus T1. So instead of T2 minus T1, we are writing CD. AC remains as such, but instead of T2 minus T1, we are writing CD. We are writing CD. Here we got this. So what you got? S is equal to AC into CD. And what is AC into CD? Simple. AC into CD is what? Area of a square or a rectangle. What do you say? Now we are doing maths. When we multiply the sides, what it becomes? It becomes area. I hope you know that. Length into breadth. Say something, please. Hello.
Yes, ma'am.
So when we multiply the size, we get area. I think you know that, right? So
Yes, ma'am.
hence we have written area of either it could be square, it could be rectangle, A, B, D, C. You have to follow like this or you have to follow like this, clockwise or anti-clockwise. It depends upon you. But it should go chronologically. You cannot take the notations in between. So either it could be clockwise or it could be anti-clockwise. I hope now it's clear to all of you.
Yes, ma'am.
Thanks. These are all graphical notations we are doing, and this will help you in maths also. How to relate. You start.
If a body whose velocity is increasing with the
Yes.
time, the graph is a straight line having an increasing slope. This is because the velocity increases by equal amounts with equal intervals of time.
Okay. It's now we are coming to a different type of category. That is, a body is there. Now, as the time is passing by, its velocity is also increasing. Graph we get a straight line, but the slope will be increasing. Now, what is slope? I will teach you. Why it is increasing? Because the velocity is increasing by equal interval of time. Velocity is increasing by equal amount, that means equal quantity with equal intervals of time. Say, read. Please read.
The area under the velocity time graph is the distance, magnitude of displacement of the body.
Okay.
The distance
Yeah.
traveled by a body between the points A and E is the area ABCDE under the velocity minus time graph.
It's velocity time graph, not minus. Okay. What it is? Velocity time graph. Now, under the area under the velocity time graph is actually what? What is velocity time graph is giving distance. That's what we did just now. Are you with me or not? Hello? So velocity time graph gives you what? What does it give you? The distance or the displacement. Now here we will see the distance traveled by the body between the points A. Now this is A and this is E. You got it? Can you see this better?
Yes, ma'am.
What is this area? A, B, C, D, and E. You understood? So we are taking this area. Got it? This complete area we are taking. This much. Got my point now? Did you understand this much? So the body is traveling between point A and E. We are getting this area as A, B, C, D. In which type of graph is given? It's velocity time graph. So the displacement is the area of A, B, C, D, E. So this is the area that we have to find out. What other areas do we have? I will magnify it. So you have to tell me. What is this area? A, B, C, D. What is this? It is rectangle. Yes? You agree upon? Do you agree upon it? And then ADE is triangle. Yes or no? So you have to add the area of rectangle and the area of triangle and you will get the displacement area. Understood? Hello?
Yes.
Okay. So what we got? Area ABCD is area of rectangle ABCD and area of triangle ADE. Fine? Now, let's go back. What is the area of rectangle AB into BC? AB into BC. At least say yes or no, please. I can expect this at least from you people. Area is AB into BC of rectangle ABCD. Is it okay with all of you?
Yes.
AB into BC. Let's see. We will check. See. Can you see over here? It is AB into BC. Now this is rectangle. This is rectangle. What is the area of triangle? Half base into height. I think you know that. Half base into height. So half base is what beta? AD. Yes? What is height? ED. Okay? So half base into height. Half AD into ED. Here. Half AD into DE or ED, whatever. We got it now? And the complete area, this complete area will be the displacement of the body. Okay, will be the displacement of the body or the distance traveled by the body. There's a complete area. Any problem? Any problem, beta? Hello?
No.
This is quite simple. I mean, if you take it that way, then it's simple. And if you take it that, oh, it's going to be difficult, then it will stay difficult. So we have come here to solve the problems. And that's the reason why I'm telling you that every slides are following. There's a connectivity between all the slides. So that's the reason why I keep on telling you again and again, please go through the uploaded video and revise. Then and then only you will be able to understand the next lecture. Fine? This is last graph that we are going to handle, and then we will start with numericals. Yes, can you read better?
Yes, ma'am.
Yeah, read it, please.
If a body whose velocity is decreasing with time, the graph is a straight line having a decreasing slope. This is because the velocity decreases by equal amounts with equal intervals of time.
Okay, what we read just now, a body whose velocity was increasing with time, we got a graph as a straight line, but it was an increasing slope. You agree? And now what we are doing? Velocity is decreasing with time, graph is straight line, no doubt about it, but the slope is decreasing. You understood now? Hello? Are you able to understand what I'm trying to say? That time the slope
Yes.
was increasing and here the slope is decreasing. That's all. The next, I will show you by graph. How does it? Yes, next, beta. Please read.
If a body whose velocity is non-uniform, the graph shows different variation. This is because the velocity changes by unequal amounts in equal intervals of time.
Now see over here. Here. It is coming from here, straight. From top it is coming down. And earlier it was from here it was going up. Yes or no? Just see. See, it was going up. From here it was going up, right? Up it is going. This is increasing slope. And now, what do you see over here? Decreasing slope. From top it is coming down. Got it now? So this is decreasing slope. Hello? I'm trying to make you understand what is called as increasing slope and what is called decreasing slope. Someone's mic is on. And in the second one, this is non-uniform. You can see the variations. See, it is going up, then comes down, again goes up, again comes down. So this is called as non-uniform motion. Any problem? So the graph tells you whether it is uniform or non-uniform. Okay? Okay?
Okay.
Okay. This is all about. There's nothing to just want to show you. If I give you a graph, what you predict? What you can say about. So this is what is written over there. That's what you have to write. That the this one shows non-uniform. That one on the left shows uniform motion, but with a decreasing slope. This one shows non-uniform motion with lots of varieties or lots of variations. This is how you have to analyze the graph. Okay?
Okay, ma'am.
As we come to a close, I think we have already taken more time. So without fail, you have to promise me that you will go through this uploaded video again, try to understand, And if at all you're not able to follow, you can call me up or we can discuss it tomorrow as well. See, I've taken only few slides today. That's the reason. And I can redo it many times. That's not a big deal. But you have to undergo this. You have to revise it. Do you promise me, beta?
Yes.
Thank you. Thank you. Okay, fine. Have a good day and we meet tomorrow. Okay?
Bye,
Bye.
ma'am.
Bye, beta. Bye.
Bye, ma'am.